Good morning, students. Today I am going to teach you material processing. So this is the second half of the unit 4, the material processing. So first topic is laser instrumentation for material processing. So how the laser it is used for the processing of material. Okay, so we'll illustrate this with a simple laser welding process. Okay, so this is the diagram construction of it. So for initially the laser source is allowed to fall on the reflecting plane surface, and because of that reflecting plane surface, everything will be reflected towards the shutter. So the purpose of the shutter is to allow the high intensity beam alone. Okay, so after that it is allowed to fall on the focusing lens assembly. So this lens assembly is used to focus or collimate the beam. Okay, okay. Next it is allowed to fall on the sample. So sample means it is the workpiece where the welding has to be done. Okay, so look at this. We have two components. One is shielding gas jet. Another one is power feeder. Okay, so I'll tell you one by one. Power feeder, it contains, powder feeder. Okay, so powder feeder, it contains metal powder. Okay, and it is sprayed. The metal powder is sprayed towards the sample. Okay, and the shielding gas jet, it is used for doing the welding process. So the word shielding gas means normally the welding, when it is accomplished on inflammable materials like glass or ceramic materials, it should be avoided. So the firing or burning should be avoided by using some shielding of gas. Okay, so that shielding will be done by this device. Okay, so basically it operates like this. So this is the device that will be the laser light will make a hole on the sample. So over the sample, the hole, the shielding gas jet will make the molten material. So when the powder feeder it sprays the metal powder, everything will be bounded. Okay, everything will be bounded over the material. Okay, and it will become a hard welding material. So during this process, in order to avoid the fire and fire accidents, some shielding will be provided. So shielding of glass. So this is the gas covered by the material. Okay, so the inside that we have a material, and the process that is going on in this, and the entire process is shielded by the gas. Okay, so it will give a cooling effect so that the fire accidents will be avoided. Okay, now let's see the laser heating. Okay, so when the laser beam or laser light is incident on a material, okay, two things will be happening. So at once it is incident on the material, part of the wave will be reflected and part will be absorbed by that material. Okay, so absorption and reflection will happen. Okay, so if the material is highly reflecting like glass material, what will happen? Nothing will be, almost all the light waves will be reflected. Okay, so if reflection is high, the the heating of the material will not happen. Okay, so our ultimate aim is to reduce the reflection and increase the absorption of the material. So if the heating is achieved on the material, it should have high absorption and the reflection should be reduced. Okay, so for that we use anti-reflection coating material, which is coated over the material, and after that the reflection will be reduced. Okay, so this absorption is measured by a factor of absorptivity. It is directly proportional to the resistivity of the material. Okay, so for, if the material is having high resistivity, that means the absorptivity will be very high. Okay, so this absorptivity nature will be greater in vapor when compared to liquid or solid. The vapor is having high absorptivity. Okay, so that means in vapor the heating can be achieved very easily. Okay, so normally when the material the reflection it is reduced, what will happen, the absorbed energy will causes lattice vibration. Lattice means the material atoms will be arranged in a certain structure, so that is called lattice. So the lattice will be the lattice vibration takes place, and when the lattice, because of this lattice vibration, the material material becomes heating. Okay, the material will be heating. Okay, so this rise of temperature, that means heating means the temperature is increased. So this rise of temperature is given by a mathematical formula, that dT by dt. So that means per second how much temperature it is increasing, changing. Okay, so that is given as Qs. Qs is the energy density of the material, and K, it is the thermal conductivity of the material, and alpha is the thermal diffusivity. Okay. Next, tau. Tau is the time constant, and it is the pulse duration of the laser, and we have exponential of Z. Z is the material thickness. Okay, so so this is the formula for finding the temperature rise per second. Okay, now let's see laser welding. Okay, so there are two types of laser welding. One is continuous and the one is pulsed. So continuous laser welding or seam laser welding, here it uses continuous laser beam for welding purpose. Okay, and the second one is pulsed or spot welding. So here pulsed lasers are used. Okay, now let's see the working of laser welding. So so just remember the block diagram that we have used for laser instrumentation of material processing. Okay, so what happens, we have a workpiece, and that workpiece the laser light is allowed to fall on the workpiece. Okay, so because of that laser light, what will happen initially, some electron or ion emission takes place. As we know, so because of the laser beam, some emission happens, some stimulated emission happens, so that will be some electron or ion emission. So because of that, some heating will be happening in that material, and some because of that heating, it starts to melt. So melting takes place. So the targeted area, the laser beam focused area will be melted, and it will be in molten state. Okay, so during the melting process, what happens, the some vaporization will also take place. Vaporization means evaporation of droplets that are present in the molten part. Okay, so and once the vaporization takes place, what happens, the thermal radiation, so some amount of radiation will be seen on that. Okay, so thermal radiation takes place. So after all process, ultrasonic vibration will happen. So because of that ultrasonic vibration, the mold and the substrate will be having a good absorption. Okay, good absorption, and it will have a good bond. Okay, because of this ultrasonic vibrations. Okay, so that's all about the working. So advantages is, since we are using a focused light beam, we can achieve micro welding. Okay, so micro welding means the thickness may be of millimeters, so even that part the welding process can be achieved. Okay, and another one advantage is the heat production is very low. Okay, so low heat release takes place because of this micro welding process. The amount of heat released is very low. Okay, and next is we have a comparison of these two lasers. CO2 lasers. CO2 lasers, carbon dioxide lasers are used for for welding the material because it is having good weld efficiency. Okay. So, because of this weld efficiency, even thick materials can be used for this welding process. First of all, what is weld efficiency? Weld efficiency, it is the ratio of the energy absorbed to the total energy or power received. Okay, it is the power absorbed. So as I have already said, once when the light beam targets on the material, two things will happen: part will be absorbed, part will be reflected. So our requirement is everything should be absorbed. So if more amount of power is absorbed, the efficiency, weld efficiency is very high. Okay, so CO2 lasers have very good weld efficiencies. Okay, and arc lasers. Okay, arc lasers are used where the reflection is very low. Okay, so it can be used for very thin materials, but you should keep it in mind that the material's reflection should be very low. That means the absorption should be very high. Okay, that's it.